Hello everyone, hope you all are doing good. Today we are going to solve an easy lead code problem. I think this is a very important problem for interview point of view. So I believe that everybody who is preparing for an interview should be able to solve this question. So let us look at the question. Roman numerals are represented by 7 different symbols: I, V, X, L, C, D and M. Here the symbol I denotes a value of 1, V is equal to 5, X is equal to 10, L is equal to 50, C is equal to 100, D is equal to 500 and M is equal to 1000 in decimal, means normal integer. So this question is saying that we are given a string, a Roman numeral in the form of a string S, and we need to convert it to a integer. Given a Roman numeral, convert it to an integer. So let us look at the examples. S is I means 1 plus 1 plus 1 is equal to 3 because I is equal to 1. So I means 1 plus 1 plus 1 which is equal to 3. Now example 2, S is equal to LVII. So L denotes 50, so 50. V denotes 5, so 50 plus 5, 55. And I means 1 plus 1 plus 1, 3. So 50 plus 5 plus 3 is equal to 58. Okay, cool. Now example 3. MCMXCIV. So M is equal to 1000. C is equal to 100. M is equal to 1000. So what will we do? 1000 plus 100 plus 1000. Don't you think this is a little bit odd? This is a little bit odd. For example, let us suppose 4 is written like this in Roman. So this is I denotes 1 and V denotes 5. So it should be 1 plus 5, 6. But no, here it is subtracted, means 5 minus 1. Why? Because I is having a value which is less than V. So if we encounter any such situation in which a character which is at a lower index is having a value lower than a character which is at a higher index, then we need to subtract those. Understood? So here M is 1000. The higher index is C, which is 100, which is lower. So we will add. So we will add 1000, then C and M. So M is having a higher value, but it is also having a higher index. So we will subtract C from M. So CM will be 900. So we will add M 1000 plus CM 900. Then XC. X is again equal to 10 and C equals to 100. Now again a higher value at a higher index. So what we will do, we will subtract 10 from 100. So this will become 90. Then again IV. V is having a higher index and a higher value, and I is having a lower index and a lower value. So we will subtract the value of I from V. So this will be equal to 4. So the answer will be 1000 plus 900 plus 90 plus 4. So 1994. Understood? This is a simple logic, and this logic was very important in able to solve all the test cases for this question. So now let us try the question. So how are we going to do? First, what we will do is that since symbol and values are given and they are fixed, so we need to store all these in a dictionary. Why are you using a dictionary? Because the dictionary is the best way to store variables if you want to reduce the time complexity. So we are storing it in a dictionary. So I have created a dictionary as such. Now we will create a variable answer which is equal to initialize as 0, and in the end we will return answer after doing all the work that is required. So now what are we going to do? Simple. We are, if you look at this example, I means we have 1 plus 1 plus 1. We have to iterate over this string. So let us initialize a variable I is equal to 0. Now while I is less than length of the string minus 1. Why I'm taking I in range of length of the string minus 1? This is because we are comparing the ith index with I plus 1th index, right? We are comparing the ith index with I plus 1th index. In case the ith index is lower than I plus 1th index, then we will consider these both as 1 and we will increment I by 2. So if you have to take, if we will take I in range of length of the string, then for the last element we will get string index out of range error. We don't want that. So I am taking I in range of length of string minus 1. Now we will compare. So how we will get the value of a string of ith index from this dictionary, right? So if for getting a value we use dictionary.get. So if the ith index is greater than the I plus 1th index, that means everything is clear and we just need to add to the answer, right? Right? And increment I by 1 because we have used only one character. But if it is not so, not just greater than here, but it should be equal to also, because in case of equal to also we are adding. But if it is lesser than, then what we have to do? We have to add the absolute difference between the value of the ith index and the value of the I plus 1th index. And then we have to increment the value by 2, because in this case we are skipping 2 characters. So we have to increment the value by 2, right? So this is the loop. We have iterated over string. Now one thing which we need to take care is that, consider this example. S is I. Okay, let us start with length of S is 3. So I is equal to 0. I is less than 3 minus 1, which is 2. So, and this condition gets satisfied. So we will add 1 to the answer, right? Now I is 1 less than 2. This condition gets satisfied. We will add 1 to the answer. Now I is 2, which is not less than 2. So the last index will be left out in this case. We cannot use equal to here. If we use equal to here, then in the last index case, we will not get I plus 1. This will give us a string index out of range error. So we have to write a separate condition for the last index if it is left, which means that if I is equal to length of the string, which means it is not considered, which means the last value is not considered, then we will add the value for the last character of the string, and then we will return the answer. Correct? Now let us try to run this and let's see. Sorry, a bracket went missing. My fault. Okay, this should be minus 1 because we are iterating on minus 1 only. We have left an equal to. Okay, let us run the code. It is passing the test case. Let us check for the example test cases. So it has passed. Now let's try to submit. Yeah, so it has been accepted. The runtime is 86 milliseconds and the memory is 13.9. So the time complexity in this case will be order of n because we are iterating over this string. So the time complexity is order of n, and the space complexity is also order of means the length of the dictionary. We are just using an additional dictionary, so it is also the space complexity will depend on the dictionary, and the time complexity on the string, which is a linear time complexity. So yeah, this was all about the question. I hope you understood it. Thank you for watching the video. Have a nice day.